attends state and national conferences, and he's an active member and has adorable children. A member of the Association of Mathematics Teacher Educators, National Council of Teachers of Mathematics, and many others. And he will help us set the stage for the rest of the conference. Please help me welcome him.
Good morning. Make sure you have something to write with and something to write on as we go through this morning's session. I'd like to thank SMU for the opportunity to be with you all this morning. A lot of my talks right now are centered around this conversation, developing problem solvers and not rule followers. The other day, The Incredibles 2 released a new trailer for a movie that's coming out. And a lot of us deal with people who keep arguing about this new math. And in this Incredibles trailer, the following scene came up. Not that's
not the way you're supposed to do it, Dad. They want us to do it.
I don't know that way. Why would they change math? Math is math. Math is math.
This is the constant battle we're fighting as we try to develop problem solvers. And think about how many parents, they want to do it the antiquated way, I gotta teach you the algorithm, etc. We're trying to break that habit. In this morning's conversation, we're gonna talk about that. We have 3 goals for this morning. Making sense of the stages of effective mathematics instruction. Talk about understanding high cognitive demand tasks and an effective instructional model. So as we think about this first goal, the big picture is just looking at what are the stages of good mathematics instruction. The first thing starts off with standards. Everybody has standards. In Texas, we have the TEKS. No matter where we go, we have standards. This is what we expect of students. The second thing we look at, what are your learning goals? When you think about your learning goals, are they specific? Are they measurable? Are they achievable? Are they results oriented? And are they time bound? But my big thing is, you have the standard that's given to you. Then you come up with your learning outcome. Thinking about this piece called task selection, implementation, and discourse. What task are you using with your students? You cannot use rote routine tasks to develop rich problem solvers. I'm going to talk about that some more. Second, think about how are you implementing the task that you're giving to your students. I see a lot of great teachers with great ideas. They start off with a great task, and then by the end of the task, it's so watered down because they spoon-fed the entire task. The next step is task discourse, allowing students to talk. Our job as educators is not to just teach, it's to facilitate a conversation among students. And then lastly, we're going to talk about this morning, the assessment piece, the assessment. So I'm going to give you a math task. Here's the standard. Apply and extend previous understandings of operations to solve problems using addition, subtraction, multiplication, and division of rational numbers. So everybody's going to start with the same standard for this task. And here's our student learning outcome. I want you to construct a valuable argument to defend your visual solution. Make sense? Now, I do this with teachers, I do the same task with students. Do not talk to your neighbor. When I give you the task, I want you to really work on it individually, and you're going to see why. Work on it individually, show your work. You have to use a visual model. So no jumping to the algorithm. You have to use a visual model. So here's the task. You have 4/5 of a pizza left. If you give 5/8 of the leftover pizza to your brother, how much of a whole pizza will your brother get? Solve this on your own. You have to use a visual and be prepared to explain and justify. And I want you all to think about something. The context is the context of a pizza. The context of a pizza. I see a lot of people drawing rectangles and different things, but Most pizzas from Pizza Hut, Papa John's, and Hungry Howie's are in the shape of a circle because the context matters. So if you started drawing your boxes, let's change that. Someone said it's easy to draw with boxes. I know, and we'll talk about that. Now, for the sake of time, next to your neighbor, explain to them what you're doing. Explain to them what you're doing. For a moment. So now, I see a lot of unique things. You have 4/5 of a pizza left. You give 5/8 of the leftover to your brother. I saw someone do this. They drew 4/5 of a pizza. Then they took out 5/8 of the pizza. And some of you are trying to draw 40ths. But tell your neighbor in like 10 seconds, what's the issue with this? Or is it right? So tell your neighbor in like 10 to 20 seconds your thoughts. Some of you are doing the same thing. I saw a lot of papers. So what are you doing? Come on back. Let's think back now. Think back to our student learning outcomes. Students will learn to multiply fractions using visuals. Also, let's think back to the problem. In the problem, it said you have 4/5 of a pizza left. So everybody agrees on the left-hand side, that's 4/5 of a pizza, correct? Okay. It said, if you give 5/8 of the what? Leftover. It didn't say 5/8 of a pizza. So turn and talk to your neighbor. How would you work through this task? So now, Mariana is going to explain what she did. So I want you all to listen up. Listen up to Mariana. You're fine, Mariana, trust me. I've done this before. So Mariana, tell us what you did.
Okay, so I divided the pizza in 5, and from those I have 4 fifths. Then that 4 fifths, I divided them, like all those slices, I divided them in half to have 8 slices of pizza, I guess. And those 5, and then I took out 5 because I gave 5 to my brother. Yeah.
So what was your result?
1, 2, 3, 4, 5. I said a half.
So now, a couple of things in that abbreviated dialogue. Notice when I very first called on her to explain, the first thing she said, no, not me. But prior to me calling on her to speak out loud, she and I had a brief dialogue so I understood her thinking. I'm not arbitrarily calling on people, I'm not arbitrarily calling on students. She had a specific response I wanted to hear and talk about. If we had more time, I would have done the same thing with this task, called on someone to talk about it. Because after I've had a dialogue with her, she can't tell me she doesn't know or doesn't understand. She's told me something. My job at that point is to build upon that something she's given me. One of the big things she said, and this task I usually take 60 to 90 minutes when I'm working with students and teachers, so this is very compressed. She said in this particular task, her brother gets 1/2 of a pizza. Because she broke it, she had 4 fifths, but then she had to take 8, make the leftover into 8ths. So she broke each leftover into 2 equal parts, and that's how she got the 5/8. Then remember the missing piece, she had to break that one up, and that's how she got the 10ths, correct, Mariana? Okay. So here's my question. Is the response, when you ask your students to explain it, should the answer be 1/2, or should the answer be 5/10? You're like 10 seconds to tell your neighbor. Should it be 1/2 or 5/10? All right, come on back. So now, Morgan said something very interesting. Morgan, what did you just say about simplifying? What do you tell your students?
Well, you tell them to simplify because...
Here's my question. She said, what? Why do you tell students to simplify?
Because the standard says they need to know it in the simplest form.
She said the standard says they need to know it in the simplest form. I've gotten previously, I simplify because my teacher told me I always have to simplify. So then I asked them, what's the mathematical reasoning for simplifying? My teacher told me I always had to simplify. I ask them again, they tell me the same thing. When we think about this whole thing as simplification, we only do it as a matter of convenience. There's no mathematical basis behind it. So don't go back and tell your students, my teacher told me, so I'm going to tell you to do the same thing. If we think about the problem for this one, yeah, some people have 1/2, some people have 5/10, some people are still at the beginning picture and they have 40ths. But when we think about the problem asked us to solve using a what model? Visual. The visual, when we talk about context, was a pizza, so it needs to be in a circle. Second, we need to think about what is visually depicted. In this problem, visually depicted is 5/10, correct? When we think about the context that you're giving the students and then what you're looking for, are you just trying to get an answer or are you trying to get them to make sense of it? The visual is 5/10. Is it equivalent to 1/2? I totally agree with you. But it's making sense of the visual. That's important because a lot of students are just going to say, I know I got to multiply these two numbers, I'm going to get an answer, I'm going to be done, give my teacher 1/2. But it's bigger than just can we get an answer? Can we make sense of the problem-solving process that goes to getting the answer? I tell my daughter's teacher this all the time. I tell her, when I was growing up, my teacher told me I'd never have a calculator everywhere I go. My daughter has an iPhone. She has a calculator everywhere she goes. We cannot keep lying to students saying, you'll never have that. They will always have a calculator. So they can always multiply and get 1/2. Siri will multiply it for you. Siri will also convert to decimals for you. But what Siri cannot do is make sense of this problem. And that's what we're trying to get with students. I tell teachers all the time, if Siri can solve your problem, you need to rethink that problem. Because when I go into workshops or go into classrooms and they give a task, I literally ask Siri to solve this task for me. And she blurts out the answer. The teacher's like, who said that? I'm like, Siri's over, it's done. Give me another task. But so think about the context of the problems that you're giving students, which leads us to assessment. The primary purpose of assessment is to gather data that supports the teaching and learning of mathematics. When a student leaves your classroom, and I just gave this task and I saw most of your work, I should know how the students are doing. I shouldn't have to wait to give them another task. I shouldn't have to give them another exit ticket. Based upon the tasks that you've given them in class, how are you assessing it? How do you know where students stand in regards to it? There's a district that, I gotta be careful not to say the name. There's a district, they have this grading policy. And this district, the district personnel and the principal told me they're focused on mastery learning. So at the very second paragraph is the cusp of this assessment policy they have. If a student makes a 60 on the first assessment, they get to retake it. I told the district person, the principal, the teacher, I think that's a good idea. They say we want to teach mastery, I understand. So if they got a 60, give them another attempt at it. The problem I have, the second iteration, they got 100. So in my mind, if you make a 60 the first time, you reassess, you make 100, which grade demonstrates your mastery at that current level? It's hopefully the 100. In this district, they take the average of the two, and it's the 80. So I'm looking at my child's grade book, and she has 80. So I asked the teacher, I'm like, so what is going on? What's her understanding? And they're like, she has an 80% mastery. But she just got 100 on the other assessment, so does she have an 80 or does she have 100% understanding? That's why we need to think about, are we making sense of assessment? So I use something, yes, when you email the district back and forth and they tell you these things, it's like, I'm still fighting these battles on a personal level also. So I use this rubric. This rubric is a plus, check, minus, 0. Because we need to think about what grades are we communicating to students and what are we communicating to parents. As a parent, when my daughter comes home with an 80%, I need to know what does that mean. Does she get, we're doing 3-digit addition right now. Does she get 3-digit addition or does she not understand it and what parts? So with this particular rubric, it's straightforward. You get a plus if you got it, you get a check if you're getting it, you get a minus if it's not yet, and you get a 0 if not enough information. So now the parent knows specifically, the student knows, and you know, where is the student at on the continuum. The reason this rubric is extremely helpful, in the great state of Texas, we have that thing called the what? STAR test. It lines up with the STAR. So if a student is getting pluses the entire year, they should demonstrate a mastery grade level on the STAR test. Think about how many times a student has gotten A's the entire year and then fails the test. So at some point, we had an honesty gap in how that student was being assessed. We have to be honest and authentic because that's problematic. Students should know and parents should know as they go along the way how my child is really faring in your class. And this rubric is pretty simple and straightforward. A book is coming out on it that we're writing this summer as it relates to classroom assessment, school-wide assessment, and how to make this a bigger picture so everyone can make sense of it. And we're not giving grades for the sake of giving grades to students. As we think about this thing we call learning, there are the 4 critical questions of learning. First, what do we want all students to know and be able to do? How will we know if they know it? The last 2 are critical. How do we respond if they do know it? How do we respond if they don't know it? The reward, if I know how to do a mathematical task, shouldn't be I get 10 more tasks to work on because I'm so good in this math. If you think about the task we have earlier, we need a rich enough task so you can continue to ask questions and let the student dive deeper in the same task. You want to think about it from the perspective of multiple entry points. Is the task rich enough for multiple students to enter it at different ways? And then, if the student knows it, they can continue to grapple with the same task. If they don't know it, we can look at a different entry point for this particular task. So I want to talk about developing an understanding of high cognitive demand tasks and task selection. And I love to use this quote. There's a difference between a hard task and a cognitively demanding task. Think about what task you're given. The goal is not to frustrate students. It's not to say, what's 999,500 million zillion divided by 7, work it out in long division. Why? That's just a complicated task. It's not cognitively demanding. We want to challenge our students. So I'm going to give you a task you're not going to work on. I'm going to set it up for the context. Write a word problem for 30 divided by 7 where the result is 2. We're typically seeing tasks, what's 30 divided by 5, what's 30 divided by 6, what's 28 divided by 4, 28 divided by 7, give me the answer. Think about, are we challenging students with the tasks that we're given? So as we think about this task, 30 divided by 7 where the result is 2, again, Siri can't answer that task. And then we think about it from this thing we call levels of cognitive demand. Is it a low-level task or a high-level task? So with that task, 30 divided by 7, you can't just memorize that answer. You can't just use a procedure. You have to use problem solving. So when you think about the tasks that you're using with your students, delineate between low-level and then high-level. If Siri can solve it, it's a low-level task. If they can use a procedure, it's a low-level task. We want the students engaging in mathematics. We want the students doing mathematics. Think about the very first task with the fractions. You really had to engage in that particular task. The task 30 divided by 7 where the result is 2. You had to engage and do the mathematics. And it's not reinventing the wheel with these tasks. In everyone's curriculum, or if you use a textbook, these tasks are in there. You just need to work together collaboratively and identify them. Think about your higher order thinking tasks at the end of all the problems. Reverse engineer it. Start with that task. Let students go through it. Because I was working with a teacher in Arkansas, and she's like, yeah, when I used to teach, she was administrator now, I used to do the 4 examples in the textbook, let my kids do 1 through 20, we'll do a couple of those, and then if we had time, we get to the word problem. And she said, if, and she said, we never had time. So reverse engineer it, because if they can do the word problem, they can do 1 through 20. And now you're slowing down your lesson. You're giving 1 to 2 tasks per lesson. You're not trying to get through 40 to 50 tasks. And then this comes from a conceptual framework. You have this task that you've taken from your curriculum materials. Impacts on the task are your knowledge and understanding of the material. So making sure within your respective school cultures, you can ask questions if you don't know how to teach it, or if you have questions about it. So then you have the task set up by the teacher, then your classroom norms influence how the task goes. Then you get to the actual task that you're implementing. Notice the very first fractions task I gave you. I just gave you the task. I didn't try to scaffold it. I didn't tell you try this method. I just said whatever method you want to come up with. I told you had to use a visual. I did tell you it had to be a pizza. But the problem solving strategy was left up to you. Because this is important, because we think about instructional practices are what impact student outcomes, student achievement. So we need to think about how does our instruction look, what type of richness is going within our instruction. And I stated earlier, do not feel you have to reinvent the wheel. Don't work collaboratively. These tasks are there. With these high, rich tasks, literally they're in your books. I'm not saying create something new. The most I do when I work with students is change the context of something that's more familiar with them. And context matters. I keep saying that for a reason. Context matters. Lastly, let's look at an effective instructional model. How many people have seen the movie Apollo 13? Oh, perfect. So I'm going to set this up. In Apollo 13, they're lost in outer space, and remember they brought all the smartest scientists in the world together, or from NASA, to make sense of it, right? So here's that clip, and we're going to talk about what happens in this clip.
We have a situation brewing with the carbon dioxide.
We have a CO2 filter problem in the module.
5 filters on the limb.
We commit for 2 guys for a day and a half. So I told the doctor,
They're already up to 8 on the gauges. Anything over 15, you get impaired judgment, blackouts, the beginnings of brain asphyxia.
What about the scrubbers in the command module? It takes white cartridges.
The ones on the limb are round.
Tell me this isn't a government operation.
It just isn't a contingency we remotely looked at.
Those CO2 levels are going to be getting toxic.
Well, I suggest you gentlemen invent a way to put a square peg in a round hole. Rapidly.
Okay, people, listen up. People upstairs handed us this one, and we gotta come through. We gotta find a way to make this fit into the hole for this, using nothing but that. Let's get it organized.
Get it, let's build a filter.
So turn and talk to your neighbor. What formula did they use? What steps were they given to solve the problem? What choices were they given for the problem? We say we're preparing students for the real world. We say we want them to become problem solvers, but yet our classrooms are not matching what we're saying we want our students to do. This was a real world situation, a real world problem. There's no formula for a real world problem. Let students use invented strategies, let them come up with strategies. Think about conceptual before procedural. Conceptual before procedural. I'm a mathematics educator. I was a computer engineering major. I teach quantitative statistics. I teach methods, research. No one has ever asked me, Chris, can you give me the formula for Pythagorean's theorem? And I do this every day. I've never had to use the formula for Pythagorean's theorem from memory and go through and just do a rote problem solving task. So if I don't do this, and I'm a math educator, why am I telling my students, you need to know Pythagorean's theorem because tomorrow you're going to use this in the real world? But what they will need are problem solving strategies to get them through a problem if something like that arises. So are you cultivating your students to become problem solvers or just rule followers? So this leads me to my favorite part of the talk. How many people use gradual release model in their classrooms? You can raise your hands high, isn't it? Everybody's like waiting for the punchline. A lot of places I go to use a gradual release model. I do, what's the rest of it? I do. How many people know where that actually came from? What did you say? You said science then? What did you say? Okay. So I hear a lot of things. Somebody said reading, somebody said some different things. Everybody points me to it came from Fisher and Freight. Okay, I agree, it does come from Fisher and Freight. The thing about this model is it was designed for literacy for Fisher and Freight. But then when you go back even further to the 1970s, they got it from Pearson and Gallagher. Guess what they designed it for? Reading. So over time, some great administrator was out at a conference. They saw this model and said, gosh, I like this. We can use this in math. The problem with it is everything falls on the teacher. You're the center of attention. You're a facilitator of these conversations. The conversation should start with the students, not with you. In my work, every child comes into the classroom with something. I've never met a kid that didn't come with something. It's our job to build upon that something. When we use this direct instruction model, what I'm saying to every kid in my classroom, you know nothing, so I have to give you everything. As opposed to, you know a lot, I'm going to build in what you bring to me to the table. So instead of thinking about this gradual release of responsibility, think about the tenets of cognitively guided instruction. Knowledge is connected. Knowledge is generative. Students describe, explain, and justify their mathematical thinking. Students identify themselves as mathematical thinkers who see that mathematics should make sense, and they have the power to make sense of it. Empower students. Give them that opportunity. They will surprise you. I was working in Atlanta, and I was doing teaching demonstrations. And then at the end of the day, we walked by an emotionally behaviorally disturbed classroom. And this wasn't on our schedule. So the principal said, I bet you cannot do what you've been doing all day. You say this problem solving stuff works with this group of students. It was the end of the day. I was feeling kind of good. I said, no, we can do it. Let's go. So as we get to the door, there's a student sitting outside, Jamal, wrapped in a blanket. He's saying every swear word in the book. And I asked the principal, is he talking to me or talking to you? I just want to be clear about his. So she's like, you said you want to do it. I said, yeah, we're going to still do it. So Jamal eventually comes in the room, wraps himself in a blanket, sits at the back table. There's another kid, if you've never been in this classroom setting, literally being restrained the entire time in the headlock. And the other kids are literally running around the room. A lot of teachers say my kids are bouncing off the walls. This is more than bouncing off the walls. So they're like, so what are you going to do? I said, I got an idea. I called the students to the front of the room. All of them came to the front. Jamal had his head down desk. He says, I'm not doing this effing math. I don't know why I'm here today. I said, I understand, Jamal. So the students come up to me. I said, how many people like pizza? They're like, we love pizza. I said, I'm going to do the problem with pizza. Slowly, Jamal comes to the front. So I'm like, great, everybody likes pizza. Jamal says, I hate effing pizza. Why are we doing pizza? I said, okay, Jamal, okay. So what do you like? I like ice cream. I said, we're going to do this. You all, we're going to talk about pizza. Jamal, we're going to do ice cream. So I give the students, I say, hey, you have 4 pizzas, 3 people, divide them up equally. They start working on this side of the board. So I went to Jamal and said, what do you like? He says, ice cream. I'm like, cool. How many people in your family? He says, 5. So we have a brief dialogue. I said, this is what we're going to do, Jamal. You have 10 tubs of ice cream. You have 5 people. How many tubs of ice cream will each person get? He said, can I label the ice cream first? I said, go ahead, Jamal. So he labels the ice cream and he starts working. So I'm going back and forth between the 2 groups. My pizza group, who were literally bouncing off the walls a moment ago, are working on the problem. They're explaining it in their own words. Jamal says, come here. I'm like, okay, what's up? He goes through and explains how he divided the 10 tubs of ice cream among his 5 family members. The same kid who earlier said, I hate math, I hate you, I don't want to be here, is working a math problem. If I would have given him a worksheet, what was that going to do for him? And a lot of people are going to go home, go thinking now, I got to print some copies when I get back from Monday's lesson. But what I gave him was a real world task. Also, I thought about, I could have made him do pizza, but is my job to force him to do something, or is my job to engage him in a context that he likes? He liked ice cream. How much harder was it for me to change his context to ice cream, my other students to pizza? What made the story even better, as we were getting ready to leave, he grabbed me and said, Dr. Childs, give me another math problem. Why? Earlier I kept saying context matters. Every kid has genius level potential. I could have easily written him off, and the principal, she was like, hey, whatever you do, just try it. After that lesson, she's like, I'm shocked. I didn't think he can do that. And I said to her, how many times do you give him the opportunity to do those things? And she's like, never. We just give them, the teacher teaches, they do a problem, they're done. What opportunities are we giving of our students? It's changing the mindset, changing the mantra, it's slowing down our lessons and really allowing the mathematics to unpack and seeing the beauty of it. Think about how you're developing these problem solvers. Think about the task that you're using. As you go through the conference sessions today, really think about that. Like I told you earlier, my tasks that I use with teachers and students when I do teaching demonstrations are 60 minutes. And we go in depth with one singular task. And then they're like, what about the routine task? Go give it to them. They can do that, trust me. But it changes how their disposition towards it. My daughter, again, we're working on 3-digit addition at home. She came home the first day. She was trying to do the algorithm. She's like, yeah, I got to carry, I got to borrow, I'm like, where are you carrying it to? Where are we borrowing from? If you borrow, you never give it back. So what I say, hey, we're going to look at strategies. And what I did, I changed it from these Wrote routine problems, I just gave her a word problem. I said, she loves Shopkins, that's her thing in my house, Shopkins. If you teach elementary, you know about Shopkins. I said, hey, you have 300 Shopkins? She's like, that's a lot. I'm like, I know, you love them that much. You have 300 Shopkins, you give your sister some Shopkins, now you have 199 Shopkins. How much did you give her? She engaged in the task and made sense of it. As opposed if I would have said, just add 300 plus 500 and do this 10 times. So think about those things as you go along the way. This stuff works, it's no gimmick. It's all about how we approach the situation. Here's my contact information. I post a lot of things on every single social media platform. You can literally people reach out to me on social media when they're trying to get in contact with me, not only even call my phone. And let me know how it goes. Like, I'm challenging everyone on Monday to use a rich task in the classroom. Let me know how it goes. I guarantee it's gonna work. The key is having the patience to do it and go through it with students and give them that time. And I challenge every audience I speak to. If it doesn't work, call me. I will come and do it for you, with you, because I know it's gonna work. So enjoy the conference. Thank you all for your time this morning. And as educators, keep doing what you're doing. You're doing a great job, and thank you for the hard work that you do every day with our students.
That was a wonderful way to start the conference. Please join me again in thanking Dr. Childs for joining us today. So we will continue to talk about applying problem solving in classrooms. Our next breakout sessions are all about designing rich mathematical tasks, implementing those in your classrooms, and really thinking deeply about that. Those breakout sessions, remember, those start at 9:35. We have the K2, 3-5, and 6-8. Right now, we are going to adjourn to the posters, so please head back out to the reception area. There's posters to view, and there's also a break, this morning break. 9:35 though, please make it back to your room, wherever you've registered for. Thank you. We're gonna